Question 1. Points A and B have coordinates 5, 2 and 10, -1 respectively. Find the equation of the perpendicular bisector of AB. Okay, when it comes to coordinate geometry, it is strongly suggested you always draw a diagram. It doesn't have to be 100% accurate, but it has to be accurate enough for you to know how to start and approach the problem. We'll plot the points 5, 2. That's A. B is 10, -1. Okay, now a perpendicular bisector is a straight line. Okay, so the perpendicular bisector of AB is a straight line that will bisect AB, will cut AB in half. In other words, the perpendicular bisector of AB will pass through the midpoint of AB. And the perpendicular bisector of AB, let's just call this line the perpendicular bisector just so we can label it. Let's call it CD. So CD will cut AB in half and CD will be perpendicular to AB. In other words, CD will cut AB at 90 degrees. And we'll call this perpendicular bisector CD. So CD will pass through M, the midpoint of line segment AB, and CD will be perpendicular to AB. This is why it's important to draw a diagram, so we can conceptualize and know how to approach the problem. So since we require, now let's go back to a perpendicular bisector is a straight line. The equation, the general equation of a straight line is y equals mx plus c. To find the equation of a straight line, we need to know the gradient and a point that lies on that line. Okay, so CD, we need to find the equation of CD. We need a point that lies on the line, which we know, or we don't know yet, but we're going to use the point M because it's the midpoint of AB. So we've got the point. We just need to find, well, we need to find the point, but we know that we need to find the gradient as well as the point. So to find the gradient of CD, we're going to first determine the gradient of AB. Because AB and CD are perpendicular to each other, the product of their gradients is -1. So the first thing we're going to do is find the coordinates of M using the midpoint formula, and then secondly, we're going to find the gradient of AB, which will then we'll be able to deduce the gradient of CD. So the midpoint of AB is x2 plus x1 over 2, that's the x coordinate. y2 plus y1 over 2, that's the y coordinate. A is the point 5, 2, B is the point 10 -1. So the midpoint of AB will be 5 plus 10 over 2, 2 minus 1 over 2, which is 15 over 2, 1 over 2. We do not write this, we do not use decimals. We're going to leave the midpoint as 15 over 2, 1 over 2. So that's 7.5 a half. If we just look, it's more or less 7.5, and that's 1 over there, and it's a half. So the diagram is drawn fairly accurately, but again, it doesn't have to be 100% accurate. It's got to be accurate enough for you to know how to start the problem. So we've got the point M. So y equals mx plus c. We've got the point that we need, which is point M. We now need to find the gradient of CD. Okay, so the gradient of AB is y2 minus y1 over x2 minus x1. So that's -1 minus 2 over 10 minus 5 minus 3 over 5. Therefore, the gradient of CD is the negative reciprocal of -3 over 5, which is 5 over 3. The gradient of AB times the gradient of CD is -1. That's because AB and CD are perpendicular to each other. Okay, we can use y equals mx plus c. It's just far quicker to use y minus y1 equals m times x minus x1 to find the equation of CD. So y minus a half equals 5 over 3 times x minus 15 over 2. y equals 5/3 x minus 12. And this is the equation of the perpendicular bisector of AB. This is the equation of CD. Next, we're required to find the equation of the circle with center A, and that passes through B. So with A being the center of the circle and B lying on the circumference of the circle, that means that AB is the radius of the circle. To find the equation of a circle, we need to know the center and the radius. The general equation of a circle is x minus a all squared plus y minus b all squared equals r squared. AB is the center. We know the center. That told us it's A. A is the point 5, 2. So we know that A is 5 and B is 2. So x minus 5 all squared plus y minus 2 all squared equals r squared. To find r, we just use the distance formula to find the length of AB. AB is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So that's the square root of 10 minus 5 all squared plus minus 1 minus 2 all squared. Square root of 5 squared is 25. Minus 3 all squared is 9. So AB equals the square root of 34. That means that r squared equals 34. So therefore the equation of the circle is x minus 5 all squared plus y minus 2 all squared equals 34. Question 2. The first, second, and third terms of an arithmetic progression are a, 2a, and a squared respectively, where a is a positive constant. Find the sum of the first 50 terms of the progression. Okay, so term 1 is a, term 2 is 2a, term 3 is a squared. We need to find the sum of the first 50 terms, so we know that n equals 50. So a equals a, the first term is a. The second term of an arithmetic progression is a plus d, so a plus d equals 2a, and therefore d equals a. The third term is a plus 2d, and that equals a squared. A equals d, so a plus 2a equals a squared. 3a equals a squared. Divide both sides by a equals 3. We can divide both sides by a because we know that a is not 0. Okay, because a represents the first term of a sequence. 2a, which is okay on its own, but 2a is the second term, which would also be 0, and the third term would also be 0. So you can't have a sequence 0, 0, 0 because that's not an arithmetic sequence. So a equals 0 is invalidated, so a equals 3. That's why we could divide both sides by a. Ordinarily, if this is a normal quadratic, you would have solved as follows. You can still do it like this, but you need to invalidate a equals 0. Whichever way you want to do it is up to you. Okay, so we know that a equals 3, so a equals 3. Since d equals a, d is also 3, n equals 50, and now we can find the sum to n terms, which is given by n over 2 times 2a plus d times n minus 1. The sum to 50 terms is 50 over 2 times 2 times 3 plus 3 times 50 minus 1 is 49, and that equals 3,825. Solve the equation. 8 cos squared theta minus 10 cos theta plus 2 equals 0 for theta is an angle between 0 and 180 degrees. Although not necessary, you can use a substitution. If you let p equal cos theta, then you'll get a quadratic in terms of p, and then you can solve for theta thereafter. You don't have to do that. You can just factorize this as it is. So cos theta equals a quarter, or cos theta equals 1. We should have actually just divided through by 2 and formed the quadratic 4 cos squared theta minus 5 cos theta plus 1 equals 0. It doesn't matter. So cos theta is a quarter, or cos theta equals 1. So we have a reference angle for cos theta equals a quarter of 75.5 degrees. The reference angle for cos theta equals 1 will be 0 degrees or 360 degrees. That's in fact the solution for that. Cos theta is positive in the first and the fourth quadrant. So the solution to cos theta equals a quarter, theta is 75.5 degrees or 360 minus 75.5, 284.5 degrees, and theta equals 0 or theta equals 360 degrees for cos theta equals 1. So these are your 4 solutions. However, the domain is theta is less than or equal to 180 and greater than 0. So we invalidate 284.5 degrees and also invalidate 360. So the solution is theta equals 0 degrees or 75.5 degrees. Find the set of values of k for which the equation 8x squared plus kx plus 2 equals 0 has no real roots. Okay. For no real roots, we know that delta is less than 0. Delta is negative. So we're going to establish the discriminant for this quadratic and then put it less than 0. So delta equals b squared minus 4ac. That's k squared minus 4 times 8 times 2. K squared minus 64. For non-real roots, delta is less than 0, so therefore k squared minus 64 is less than 0. We now have a standard quadratic inequality to solve. So k plus 8 times k minus 8 is less than 0. The critical values are minus 8 and 8. Draw a sketch. These critical values are the x-intercepts of this corresponding quadratic function. So it's minus 8 and 8. We are looking, because the inequality is less than, we're looking for negative y values. So we are looking for where the function, the k values for where the function lies beneath the x-axis, which is between the two x-intercepts of the function. So the solution is k is less than 8 and greater than minus 8. Question 4. A geometric progression is such that the third term is 1764 and the sum of the second and third terms is 3444. Find the 50th term. Okay, so we have a GS. The third term is 1764 and the third term of a GS is given by AR squared. So AR squared is 1764. The second and third terms, the sum of the second and third terms is 3444. So term 2 plus term 3 is 3444. The general term for the second term of a GS is AR. The third term is AR squared equals 3444. AR squared is 1764. So AR plus 1764 equals 3444. AR equals 1680. Okay, we now have two equations that relate A to R, so we can either isolate a variable and substitute and use simultaneous equations, or we can just divide these two, would be the simplest thing to do. So the a's will cancel. R squared divided by r is r. 1764 over 1680 is 21 over 20. So we've got our common ratio. AR equals 1680. A is 1680 over 21 over 20. So A equals 1600. And we want the 50th term. So the 50th term equals AR to the 49. So that's 1600 times 21 over 20 to the 49. And we can leave it in this form. Question 5. The graph with equation y equals f of x is transformed to the graph with equation y equals g of x by stretching the x direction with the factor of a half followed by translation of 0, 1. We're given the diagram of y equals f of x. On the diagram, sketch the graph of g of x. Okay, so the first transformation is a stretch in the x direction. So when we stretch in the x direction, y equals f of x, that's stretch, a factor of 0.5. So the first transformation is a stretch in the x direction with a scale factor of 0.5 or a half. Now recall that the function y equals f of ax is the function y equals f of x stretched horizontally in the x direction with a scale factor of 1 over a. So the fact that this scale factor is a half, we have got 1 over a half, which is 2. So the first transformation, stretch in the x direction with a scale factor of a half, means that y equals f of 2x. Now what that means when we're sketching the graph, when you're sketching the function, whatever this function is, we don't know the equation of it, we're taking every single x coordinate on this function and we're halving it, and then we'll just put straight lines through that. So half of 0 is still 0. The x coordinate here is 1, so at the same height we will be at a half. This x coordinate is 2, so at the same height we half 2, and that will be 1. This x coordinate is 3, half of that is 1.5, but at the same height, so 1.5 will be there. And then this x coordinate is 4, and half of that is 2 at the same height, so we will be at that point. Now the second transformation is a translation of the vector 0, 1. The x coordinates will not change, but the y coordinates will be shifted up 1. So every single point, in other words, every single point on this dotted function is going to shift up 1 unit. That blue function now is the transformed shape y equals g of x. Find an expression for g of x in terms of f of x. So the first thing we did was a horizontal stretch of a half. So the scale factor is a half, which means that we have f of 2x, and then it was a translation by the vector 0, 1. So x did not move with a vertical stretch, so we just add 1. So this is g of x in terms of f of x. Question 6. The equation of a curve is given by y equals 4x squared plus 20x plus 6. Express the equation in this form, which is turning point form, or completing the square form, where a, b, and c are constants. So y equals 4x squared plus 20x plus 6. The first thing we do always when completing the square is ensure the coefficient of x squared is 1. The coefficient of x squared is 4, so we divide every term by 4. 4 times x squared plus 5x plus 6 over 4 is 3 over 2. Equals 4 times x squared plus 5x. We now add a bracket squared plus 3 over 2, and then subtract that same bracket squared. Inside the bracket is half the coefficient of x, so half of 5 is 5 over 2. It equals 4 times the first three terms here form the perfect square trinomial x plus 5 over 2 all squared plus 3 over 2 minus 25 over 4. That's 4 times x plus 5 over 2 all squared minus 19 over 4. And then just bringing the 4 in, we'll just write it over here. Y equals 4 times x plus 5 over 2 all squared minus 19. And this is now in the required form. So comparing it to this, A is 4, B is 5 over 2, C is minus 19. And solve the equation 4x squared plus 20x plus 6 equals 45. Okay, so this expression here is 4 times x plus 5 over 2 all squared minus 19, and that equals 45. So 4 times x plus 5 over 2 all squared equals 64. Divide both sides by 4. X plus 5 over 2 all squared equals 16. You can now square root both sides. X plus 5 over 2 is plus or minus the square root of 16, which is 4. X equals minus 5 over 2 plus or minus 4. X is minus 5 over 2 plus 4, or x is minus 5 over 2 minus 4. So x equals minus 5 plus 8. It's going to be 3 over 2. Or x equals minus 5 minus 8 minus 13 over 2. So x equals 3 over 2 or minus 13 over 2. Sketch the graph of y equals 4x squared plus 20x plus 6, showing the coordinates of the stationary point. You're not required to indicate where the curve crosses the x and y axes. Okay, so the function is y equals 4 times x plus 5 over 2 all squared minus 19. The turning point, the stationary point, this is a quadratic function. The turning point is minus 5 over 2 minus 19. And we just need to plot the turning point, minus 2.5 minus 19. We'll call that point A. And the y-intercept is 6. So we have a y-intercept there. That said, you don't have to indicate, but it's important that you know where it cuts the y-axis at plus 6. We have the axis of symmetry at x equals minus 5 over 2, which is that dotted line. And now we just draw a smooth curve through the 2 points. Question 7. Prove the identity sine theta over sine theta plus cos theta over sine theta minus cos theta equals tan squared theta plus 1 over tan squared theta minus 1. Now, general rule of thumb when proving trigonometric identities is to start with the more complex looking side. So we're going to start with the left hand side. And the first thing we're going to do is establish a lowest common denominator, which is sine theta plus cos theta times sine theta minus cos theta. So we'll have sine theta times sine theta minus cos theta plus cos theta times sine theta plus cos theta in the numerator. Now we just multiply out in the numerator and simplify as far as possible. Now, before we do that, just note that the denominator on the right hand side is tan squared theta minus 1. The fact that we've got a squared identity here means we are going to multiply out the denominator on the left. Generally speaking, a denominator is always in factorized form, but in this case, because we're trying to get a squared term in the denominator on the right hand side, we're going to multiply out the denominator as well. So at the top we have sine theta times sine theta, which is sine squared theta, sine theta times minus cos theta minus sine theta cos theta, plus sine theta cos theta plus cos squared theta over sine squared theta minus cos squared theta. On the left, sine squared theta plus cos squared theta equals 1. That's from the square identity. Minus sine theta cos theta plus sine theta cos theta is 0. So we just have 1 in the numerator. And we have sine squared theta minus cos squared theta in the denominator. Now, the fact that we need a tan squared out of this on the right hand side, we're going to divide the numerator and the denominator by cos squared theta. How you go about manipulating and showing that this is going to equal tan squared theta plus 1 over tan squared theta minus 1 is up to you. This is just one approach, dividing by cos squared theta. So we'll have 1 over cos squared theta over sine squared theta over cos squared theta minus cos squared theta over cos squared theta. That equals 1 over cos squared theta over sine squared over cos squared is tan squared. So we have tan squared theta minus cos squared divided by cos squared is minus 1. So immediately we have got the denominator that we're looking for. Okay, now we do not deal with reciprocal trigonometric ratios. However, I'm going to continue this as if we did do reciprocal ratios, and then I'm going to approach the same problem but in a different way. 1 over cos squared theta equals sec squared theta, and sec squared theta equals tan squared theta plus 1. So this is yet another trigonometric square identity, which you can easily prove in the cast diagram. So we have sec squared theta over tan squared theta minus 1, and sec squared is tan squared theta plus 1 over tan squared theta minus 1. For those that haven't, in pure maths paper 1, we don't deal with reciprocal trigonometric ratios, identities. So we are going to approach the problem but in a different way. It's probably instinctive to write sine squared theta plus cos squared theta as 1, as we did previously. However, because we're looking for this expression over here, tan squared theta plus 1 over tan squared theta minus 1, we're looking for tan, and we know that tan theta is sine theta over cos theta. So if we divide every single one of these terms in the numerator and denominator by cos squared theta, then we're going to have sine squared theta over cos squared theta plus cos squared theta over cos squared theta over sine squared theta over cos squared theta minus cos squared theta over cos squared theta. And that's going to be sine squared over cos squared is tan squared. Cos squared over cos squared is 1. Sine squared over cos squared is tan squared. Minus cos squared over cos squared is minus 1. And we get the right hand side. Hence find the exact solutions of the equation sine theta over sine theta plus cos theta over sine theta minus cos theta equals 2 for theta is an angle between 0 and pi. Okay, so this expression here we have just shown is tan squared theta plus 1 over tan squared theta minus 1. And to solve a trigonometric equation, we can only do so if we have a single trig ratio. So that's why we reduced this fraction to tan squared theta plus 1 over tan squared theta minus 1. We can now equate that to 2. We've got a single trig ratio here. We can now solve for theta. So getting rid of the denominator, tan squared theta plus 1 equals 2 times tan squared theta minus 1. Square rooting both sides, tan theta equals plus or minus the square root of 3. Okay, the reference angle, if we were working in degrees, would give us theta is 60 degrees, but in radians, this would be pi by 3. So the reference angle is pi by 3 because we have a domain here, we have a restriction, right? But we're first going to list all 4 solutions and then invalidate the ones that do not apply. So theta will be pi by 3, that's in quadrant 1. Quadrant 2 will be pi minus pi by 3, which is 2 pi by 3. Quadrant 3 is pi plus. We don't have to go to quadrant 3 and 4 because this is quadrants 1 and 2. We don't have to go any further, but I will for completeness sake. Pi plus pi by 3 will be 4 pi by 3. And then in the fourth quadrant, we'll have 2 pi minus pi by 3, which is 5 pi by 3. Now, theta is an angle between 0 and pi, so only quadrants 1 and 2, which means that theta is pi by 3 or 2 pi by 3. These will be invalidated. Question 8. The equation of a curve is such that dy dx equals 3x to the half minus 3x to the minus a half. The curve passes through the point 35. We're required to find the equation of the curve. Okay, so we are given the gradient function of a curve. And we're required to find the equation of the curve. So to find the equation of the curve, we will be integrating these expressions. So y equals 3x to the half plus 1, x to the 3 over 2, divided by 3 over 2, minus 3x to the minus a half, plus 1, so 3x to the half, and we divide by a half, and we add the constant of integration. So y equals 3 divided by 3 over 2 will be 2. So it's 2x to the 3 over 2 minus 3 divided by half is 6, 6x to the half plus c. This is the equation of the curve. We now need to find the constant of integration, and we do that by substituting the point that lies on the curve, which is the point 3, 5. So 5 equals 2 times 3 to the 3 over 2 minus 6 times 3 to the half plus c. 2 times the square root of 27 minus 6 root 3 plus c. 5 equals 2 times 3 root 3 minus 6 root 3 plus c. 5 equals 6 root 3 minus 6 root 3 plus c. Therefore, c equals 5. So the curve is given by y equals 2x to the 3 over 2 minus 6x to the half plus 5. We're now required to find the x-coordinate of the stationary point. So, firstly, for stationary points, the gradient function equals 0, dy dx equals 0. Dy dx equals 3x to the half minus 3x to the minus a half. So for stationary points, 3x to the half minus 3x to the minus a half equals 0. We can divide through by 3 because it's not 0. X to the half minus x to the minus a half equals 0. Okay, so x to the half minus 1 over x to the half equals 0. Root x minus 1 over root x equals 0. I'm just doing it this way because it's just neater to work with the surd. Multiply through, x cannot equal 0. Multiply through by root x, and we'll have x minus 1 equals 0. So x equals 1. So the x-coordinate of the stationary point is 1. State the set of values of x for which y increases as x increases. So we're talking about an increasing function. And this happens when the gradient function is greater than 0, when the gradient function is positive. So dy dx, or f prime x, whichever way you want to look at it, 3x to the half minus 3x to the minus a half, this expression must be greater than 0 for the function f to be increasing, or for the curve to be increasing, an increasing function. So 3x to the half minus 3x to the minus a half must be greater than 0. Again, divide through by 3, and we can write this as root x minus 1 over root x is greater than 0. So x minus 1 is greater than 0, x is greater than 1. So if x is greater than 1, then we'll have an increasing function. Question 9. Functions f and g are defined by f of x equals x plus 1 over x for x is greater than 0, g of x equals ax plus 1 for x is any real number. A is a constant. Find an expression for g of f. So g of f will be g of x plus 1 over x, which is a times x plus 1 over x plus 1. That's ax plus a over x plus 1. Given that g of f of 2 is 11, find the value of a. So g of f of x is ax plus a over x plus 1. And we're told that g of f of 2 is 11. So g of f of 2 will be, we're substituting 2 for x, so it'll be 2a plus a over 2 plus 1. And g of f of 2 is 11. So 11 equals 2a plus a over 2 plus 1. We get rid of the denominator immediately. So multiply everything by 2. 22 equals 4a plus a plus 2. 20 equals 5a. A equals 4. Now the domain of f of x is greater than 0. So if we will have f will have an inverse if it's a one-to-one function. So if we can show that f is one-to-one, then it will have an inverse. Now for a one-to-one function to exist, one input value must yield only one output value. So if we have f of 2, we'll get 2 plus 1 over 2, which is 5 over 2. F of a half is going to be a half plus 1 over half. That's a half plus 2, which again is 5 over 2. Now for two inputs, we are getting one output, right? When x is a half or 2, we're getting the same output of 5 over 2 or 2.5. So this would be a many to one function, which is certainly not a one-to-one function. So therefore, f would not have an inverse because it's not a one-to-one function. It's given instead that a equals 5. Find and simplify an expression for g to the minus 1 f of x. Okay, so f of x is x plus 1 over x. X is greater than 0. G of x is ax plus 1, so it's going to be 5x plus 1. So the inverse of g will be x equals 5y plus 1, x minus 1 equals 5y, y is x minus 1 over 5. So g to the minus 1 of f is g to the minus 1 of x plus 1 over x, which is x plus 1 over x minus 1 over 5. Okay, that equals x squared plus 1 minus x over x over. So g to the minus 1 of f equals x squared minus x plus 1 over 5x. Explain why the composite function f of g cannot be formed. The function f of g can only exist if the range of g falls within the domain of f. Question 10. The diagram shows a cross-section RASB of the body of an aircraft. The cross-section consists of a sector OARB of a circle of radius 2.5 meters, center O, a sector PASB of another circle of radius 2.24 meters with center P, and a quadrilateral OAPB. Angle AOB is 2/3 pi and angle APB is 5/6 pi. Find the perimeter of the cross-section RASB, giving your answer correct to 2 decimal places. Okay, so to find the perimeter of RASB, we have this arc length ARB of sector OARB, and then we have arc length ASB of sector PASB. So the arc length ARB, let's just highlight the sector. So we need to know what the arc angle is, and the arc angle is this, which we will call theta. Now, this angle here is 2 pi by 3 radians. So to find theta, theta plus 2 pi by 3 is a complete revolution, which is 2 pi. So theta is 2 pi minus 2 pi by 3. It's going to be 6 pi minus 2 pi. It's going to be 4 pi by 3. So theta is 4 pi by 3 radians. So the arc length ARB is just going to be the radius of that sector, which is 2.5 meters, times the arc angle, 4 pi by 3. And then similarly, arc length ASB is formed from sector A PASB. So the radius of that sector is 2.24. The arc angle is this angle here, which is 5 pi by 6. So the perimeter of RASB is 26 pi by 5, which is 16.34 meters approximately. Find the difference in area of the two triangles AOB and APB, giving your answer correct to 2 decimal places. So starting with triangle AOB, the area of the triangle, we can use the sine rule here. Okay, let's first just mark off what we know. AO and OB are radii. So OA equals OB equals 2.5 meters. So we've got two sides and we've got the included angle of 2 pi by 3. So the area of triangle AOB is going to be a half 2.5 times 2.5 sine of the included angle, sine 2 pi by 3. So that equals, which is approximately 2.71 meters squared. Similarly, to find the area of triangle APB, we have PA being equal to PB, which is 2.24 meters, and we've got the included angle, which is 5 pi by 6. So the area of triangle APB is going to be a half 2.24 times 2.24 sine 5 pi by 6, 1.25 meters squared. Area triangle AOB minus area triangle APB is 2.71 minus 1.25, which is 1.455. We'll leave it as 1.45 meters squared. Next, we're required to find the area of the cross-section RASB, giving the answer correct to 1 decimal place. So the area of RASB equals the area of sector OARB is going to be a half radius squared times the arc angle. The radius squared is 2.5, so it's 2.5 squared times the arc angle, 4 pi by 3, plus the area of sector PASB is a half. The radius squared is 2.24. 2.24 squared. The arc angle is 5 pi by 6. And the area of the purple shaded region is what we just determined in the previous question, is 1.45. So the area of RASB equals 21.11 square meters. Question 11. Find the coordinates of the minimum point of the curve y equals 9/4 x squared minus 12x plus 18. Okay, so for minimum points or maximum points, we're talking about stationary points. So for stationary points of a curve, the gradient function equals 0. So dy dx equals 0. So differentiating this function, dy dx equals 9/4 times 2. It's going to be 9/2x minus 12, and that equals 0. So 9x minus 24 equals 0. 9x equals 24. X is 24/9. So if we call y f of x, then f of 24/9 is 9/4 times 24/9 squared minus 12 times 24/9 plus 18. That equals 2. So the minimum point, stationary point, is 24/9, 2. The diagram shows the curves with equations y equals 9/4 x squared minus 12x plus 18 and y equals 18 minus 3/8 x to the 5/2. The curves intersect at the points 0, 18 and 4, 6. So first point here, A, is 0, 18, and at B is the point 4, 6. Find the area of the shaded region. So the area of the shaded region is the integral between from x equals 0 to x equals 4. Those are your boundaries of integration, the x values, the boundaries of integration. The top curve, so we're going to call, we already called this function over here f of x, so let's just stick to that convention and we'll call this function over here g of x. So top curve minus bottom curve will be g of x minus f of x, and we integrate with respect to x. And now we're ready to integrate. So we have the integral of 18 is 18x minus 3/8. X to the 5/2, we add 1 to 5/2, so it's going to be x to the 7/2. And then we multiply by 1/7/2, so we're multiplying by 2/7 minus 9/4 x to the 2 plus 1, x to the 3, and then divide by 3, so we're multiplying by 1/3 plus 12x squared over 2 minus 18x between x equals 0 and x equals 4. We could have just cancelled 18 minus 18. It equals minus 3/28, 2 squared to the 7/2, minus 3/4, 4 cubed, plus 6 times 4 squared. When x equals 0, every single one of these terms will be 0. So that's minus 3/28 times 2 to the 7 minus 3/4 times 64 plus 6 times 16 is 96. So the area of the shaded region equals 240/7 units squared, which is approximately 34.28, 34.3 units squared. Point P is moving along the curve y equals 18 minus 3/8 x to the 5/2 in such a way that the x coordinate of P is increasing at a constant rate of 2 units per second. Find the rate at which the y coordinate of P is changing when x equals 4. Okay, so let's start over here. We have a point P moving along a curve in such a way that the x-coordinate of P is increasing at a constant rate of 2 units per second. So increasing, the word increasing implies positive change, but it implies change. Rate is per unit time, and the x-coordinate is changing. So we're talking about dx, the rate of change of the x-coordinate, dx dt. This is the differential that we are getting from that, and that equals 2 units per second. We're required to find the rate at which the y-coordinate is changing. So if the y-coordinate is changing, we're looking for the change in y, and the rate is per unit time. So we're looking for the differential dy dt. We now need a differential that's going to relate dy dt to dx dt, and that differential comes from the curve itself. So y equals 18 minus 3 over 8 x to the 5 over 2. The differential we get from this is dy dx, and then this differential dy dx will relate to dx dt and dy dt. So the first thing we do is differentiate this dy dx. The derivative or constant is going to be 0. So then we have minus 3 over 8 times 5 over 2, x to the 5 over 2 minus 1. That will be x to the 3 over 2. Then equals minus 15 over 16 x to the 3 over 2. We now need to relate dy dx to dx dt and dy dt. So we're going to set up a formula, an equation. Dy dt is dy dx times dx dt equals dy dx minus 15 over 16 x to the 3 over 2 times dx dt, which is 2. So that's going to be minus 15 over 8 x to the 3 over 2. We now have the differential dy dt. So dy dt when x equals 4 is minus 15 over 8 times 2 squared to the 3 over 2 minus 15 over 8 times 2 cubed, which will be minus 15.